Anybody have any homework questions? All right. So last time we started working on this. We had this horizontal member that's 0.8 meters long, and it's connected by a pin joint to this diagonal member. And this is 1 meter, that's 0.8 meters. This distance here is 0.6 meters. And I ignored the weight, but at this pin here, there was a force of 1,000 newtons. And so far, okay, well, we numbered these members. We called this member 1 and this member 2. And this was A, B, and C, the pins. And from isolating member 1, we got the first 3 equations. RAX plus F12X is equal to 0. RAY plus F12Y is equal to 1,000. And 0.8 F12Y is equal to 800. You asked if, so you can see right away, because we're human beings, not computers, you know, we can look at this and see like, oh, that tells us what F12Y is. Can we just solve for that and then get it out of the equation? Sure, that's fine. But you can imagine the benefit if you're writing a computer program or something to do this, to just always do it the same way, come up with the full system, solve the full system. You can tell a computer to do that without any trouble. Okay, so those are the first 3 equations, and now we're going to member 2. And member 2 makes contact with, okay, so down here at the joint C, there's only one numbered member. So we're going to think of the pin as part of member 2. And I'm just going to call this RC. Why would I call that RC and not F on 2 by the ground or something, F2G, you know?
The Newton's third law equation isn't going to show up again.
Yeah, that's exactly right. So that double subscript notation where the first subscript is the body that it's acting on, and the second subscript is the body that's applying the force. The use of that is Newton's third law. You flip the subscripts, you flip the sign. Okay, we're not ever gonna isolate the ground, so we're never gonna use Newton's third law and at this joint. And so you can do that, but there's no reason to, it doesn't help. Okay, and then up at the other joint, normally we have the weight in here, but this time there's no weight. So what force or forces are acting on member 2 at that joint B? This just takes a little bit of careful thinking, you know? So yeah, so there's this force. So this is the force on 2 by 1, right? Well, we don't want to write it that way because we already have a force F12. So we want to use Newton's third law here to make that the same force. Okay, that's so that we have the minimum number of variables. So this is going to be negative F12. Yeah.
Can we just jump right to that conclusion?
Yes.
We have to show.
No, that's fine. Yeah. I'm just trying to make it clear, you know. Okay, so there's definitely the force on 2 by 1, and that's what we have represented. What about that 1,000 Newton force?
I think we shouldn't account for it, else we'd be counting it twice.
Exactly. So that force is only applied once. If you apply it to this body, your answers will be like, this is a 2,000 Newton force. Okay? And if you look at a problem and maybe like the way this is drawn, this looks to you like this is 1,000 Newtons applied to body 2 for some reason, okay? That's fine, do that. But if you're gonna treat it like it's acting at the pin, then you have to put it on the joint, on the member that contains the pin, okay? The lowest numbered member at B is body 1. So I'm including this as body 1. Any questions about that? You could do it as 200 on 1 and 800 on 2, but that would be really unnecessarily complicated. Anybody have any questions about that? Okay. So we have that 1,000 acting on member 1. So this is it for member 2. So now we'll go rho, force, moment. The about point I'll do over here. So first I'll do RC. The rho vector is 0. Force vector is R, CX, RCY. Cross product is 0. And then I'll do F, negative F12. The rho vector there is positive 0.8, positive 0.6. Force vector is negative F12x, negative F12y. So see the negatives showing up in those components. And then the cross product is negative 0.8 F12y plus 0.6 F12x. And so our fourth equation, remember we get 3 equations for every rigid body. So the first one says RCX minus F12x is equal to 0. Our second one says RCY minus F12y is equal to 0. And our sixth equation says negative, I'm going to reorder these, 0.6 F12x minus 0.8 F12y is equal to 0. Okay, so we have 6 equations. How many variables do we have? Bless you. Yeah, so we have RA, X and Y components, F12, X and Y components. We didn't add any more here because we use Newton's third law. And then we have RC, X and Y components. So the variables are F F1, 2 vector, RA vector, RC vector. So we have 6 equations. We need 6 rows. And we have 6 variables plus a constant. So here's equation 1, 2, 3, 4, 5, 6. And variables, I'll go F12x, F12y, RAX, RAY, RCX, RCY, and the constants. Okay, so for equation 1 from body 1, RAX's we have 1, F12x's we have 1, everything else is 0. For body 2, RAY's we have 1, F12y's we have 1, constants are 1,000, the rest are zeros. And the third one says F12y, we have 0.8, and the constant is 800. Now equation 4, RCX's, we have 1. F12x's, we have -1. Equation 5, RCY's, we have 1. F12y's, we have -1. F12x's, we have 0.6. F12y's, we have -0.8. And then zeros. Okay, now, all right, and what I get is F1, 2 is equal to -1333.3 repeating 0. RA is equal to -1333.3 repeating 0. And RC is equal to 1333.3 repeating 1,000. Okay, and compared to the other way of doing this, there are differences in the names because we renamed the members. But even still, like, we got a contact force the first time through, F12, that's equal to 1333, 1,000. And look at it here. We got -1333, 0. It's in a totally different direction, you know? It's not parallel to the old one. And so just glancing at it, it's not clear that these are telling you the same thing. It only becomes clear when you draw the free body diagram. So let's go to the free body diagram. So F12, free body diagram of body 1. So down here, we have RC. That's 1333.3 repeating 1,000. And up here, we have the force on 1/2. And we also have the downward force of 1,000. And so if you combine the force vectors acting at that same spot, you get 1333.3 repeating, 1000 down here. And up here, you get negative 1333.3 repeating, negative 1000. So both of these two force vectors are along the long axis of that member. They're towards each other. So this beam is in compression. And you can see that it tells the exact same story as this. Okay? And free body diagram of body 2. You have RA over here. That's negative 1333.3 repeating 0. Over here, it's positive 1333.3 repeating 0. So this member is in tension. Those two forces are away from each other, parallel to each other. The magnitude is 1333. And if you look up at the first way of doing it, they tell the same story again. Okay? So changing the numbering of the bodies will change the answers you get for your forces, but the meaning of those forces is the same. It's totally arbitrary how you number this stuff. Okay? Okay, for doing these problems, this is crucial. Don't ask me about real quizzes. This is a fake quiz. What's the double subscript notation for the force on body 3 by body 1? Okay, answer that in your own head. Commit to something. Okay, the first subscript is the one that the force is acting on. So this is F on 3 by 1. And normally then what I didn't ask is, if you're going through these in order, if you get a force F on 3 by 1, you're always going to already have a force on 1 by body 2. And so then you'd use Newton's third law and call this negative F13. Okay. How can these problems get more tricky? There's really only one way to make this tricky. Once you sort of have the system down, and that is to have more than 2 bodies connecting at a single joint. Okay? So what happens if 3 or more bodies connect at a joint? We'll do a couple examples like this. But here's what I want you to notice. So if you have, let's say, we're looking at a side view, and this has a body like that, a body like that, and another body like that, and they're all connected by a pin. And then, you know, there's some force here, let's say 1500 newtons or something. Let's say this is body 1, body 2, body 3. Okay. Well, we're going to include the pin as part of member 1. So all the shaded stuff is member 1. Okay. And the stuff that can be really confusing that you have to be careful about is bodies 2 and 3 don't touch. Okay? So, in the free body diagram of body 1, there's a 1500. There's an F12, and there's an F13. In the free body diagram for member 2, what forces does member 2 see?
Negative F1.
Yep. Negative F12. Anything else? Nope, that's it. Okay. And then same thing with member 3. The only thing that member 3 touches is the blue pin. So negative F13. Okay. Anybody have any questions? That's it. So I'm just going to keep giving you these problems. And next time in class, I'll just write a problem up on the board and you can work in groups or whatever. And I'm just going to give you some time now to sort of sort this stuff out in your head. Okay.
Fine, cool.